Okay, day 6. Confidence interval for slope. We can find an interval of plausible values for the slope, just like we did for proportions and means. The general form stays the same. The confidence interval is going to be our point estimate plus or minus our margin of error, just like we've done all semester. Conditions are slightly different though. So we're still going to check random. Does the data come from a random sample or not? Normal. Is it approximately normal? And then, like we talked about the last few days, linear appropriate. So here's where we're going to look at the residual graph. Slide. Look at residual graph. And remember, when we're looking at a residual graph, if it's just a random pattern, a line is appropriate. But if we have a curvy thing, shaped like a curve, a line isn't appropriate. So if these are met, we can use our calculators. And this is all going to be calculator based. So here's the formula. The confidence interval is going to be our B, which is our slope. Okay? T is our critical value. Okay? And our DF, degrees of freedom, is going to be n minus 2. So, a few quick things. SB is the standard error of the slope. It describes how variable the sample slope is for given sample size. This is different from S, which is the standard deviation for the residuals, although they're related. Okay? So on the TIA3, S is SE, not S, the little symbol there. And then on TIA3, after regression line is calculated, the residuals are stored in a list we call resid. So we talked about how to do that, and your calculator should all have that still in there. If not, we can adjust. All right, so this is the time-consuming part. If basically wants to know in this study, is it better to sit closer to the board? Do you get better grades the closer you are? So here are 30 scores. To make it easy for you, listen before you start putting this out in your calculator. If you count or notice, it's like a square classroom. So when you're putting in list 1, there's 6 1s, there's 6 2s, 6 3s, 6 4s, and 6 5s. So as we're in the calculator, which you're going to do right now, I'm going to hit pause here in a little bit, but you're going to go to stat, like we've been doing, enter, okay? I actually already have it in here, so I'm just going to leave it. No, that one changed. Never mind. I got to do this. So go into your L1, clear it out, come down. Go into L2, clear it out, come down. Go into your residuals, go up and clear it out, come down. Then go back over to L1. And all you're going to do is you're going to put in 6 1s here. Okay, then you're going to put in 6 2s and so forth. After you do that, you're going to put the scores, 76, 77, and so forth, in L2. And I want to hit pause while we enter in our calculator. All right, so we have all of our data entered. Okay? Now let this disappear for a second. Now, this funky looking capital B is beta, Greek symbol. So as always, we're going to define our parameter. So we're going to write kind of a cursive-y little curvy B, just whatever. Don't make it a really block B. Make it kind of fancy just to show that it's beta. Okay, what is beta? Okay, and this is going to be our tagline. It's the true slope of the line. This is going to be the standard every time. True slope of the line. Relating. Okay, so that's the standard. The true slope of the line relating. That's just standard thing we're going to say every time. And then all we look at is those words. Row, we're going to put an X in there, to score. We're going to put parentheses Y. So it's the true slope of the line relating row to score. Okay? And now we just get to the math. Now there's going to be a little bit different. Okay? But it's all right here. The procedure's right here. So if I take your calculator, we have everything in for L1 and L2. This is different. Everybody hit stat. Now we're going to go over to tests. You can go twice to the right or one time to the left. And we want G. So I'm going to arrow up towards the bottom. And there it is. G, linear regression T interval. And you hit enter. Now this should probably be set up for you. But just to make sure, remember, if for some reason that says L3, how do we change it to L1? Second 1. So if it's not right, make sure you have L1, L2, frequency 1, and it's on this box here for you. Confidence level, 95%, which is already probably in your calculator, but if it's not, just change it. Only thing we have to do is come down here to rep EQ and put alpha, trace, and pick Y1. And now you're just going to go down and calculate. And here's a lot of information. Okay? Now, the thing in parentheses is our interval, our range. So right now, we're going to write down at the top of this page here, we're going to put our interval and just write negative 4.245, comma, 1.212. Just write down that interval. Now, as a reminder, our formula is y hat equals a plus bx. So we're just going to take our a and our b right from there. A is 85.95, and b is negative 1.52 rounded. So we're going to write y hat equals 85.95 minus 1.52x, and if you write plus negative 1.52, that's okay. I did it on my paper, actually. And we're actually almost done. We just need to make one of our usual long-winded statements. So, we are 95% confident, okay, this is standard, that the interval from and where are we going to get that interval from? Right from what we just wrote down up here. Negative 4.245 to 1.212. And now we're just going to copy our B down, our beta, and say captures, and now we just copy beta. The true slope of the line relating row, parentheses x, to score, parentheses y. Boom, that's it. Okay, so now we're going to take our calculators and enter these new data in. So stat, edit, clear out L1, clear out L2, clear out resid. Go back to L1, enter the data in, and I will hit pause. Okay, so we have everything entered in. We're going to do our fancy looking B, a little curvy. So what are we looking at? Again, it's the same sentence over and over. True slope of the line relating. That's all you write. True slope of the line relating. And what are we looking at? Steps and calories burned. So steps, parentheses x, 2 calories burned, parentheses y. Very simple statement. True slope of the line relating basically x to y. Once we have that written, we pull up our calculator. We're going to do the same thing. Stat, tests, up to G, enter, L1, L2. Notice in this one, since I already did this with the previous problem, it's already ready to go. I already have y1 in there. I just hit enter a bunch of times, and there I am. I've got my data right there. So my range, 0396 to 11342. So we write that down. Parentheses, 0.0396, whoops, 96 to 0.11342. We look on our calculator for our A and B. Y hat equals 1949.15 plus 0.08x. Where did those come from? Right there. There's my A and there's my B. I rounded the 0.076 to 0.08. At this point, we just write our statement. And our statement is, same thing. We are 95% confident that the interval from, and where do we get that? Right above in the parentheses. Just copy it down, 0.0396 to 0.11342, and then we figure out, we write the same thing again. Captures the true slope of the line and then containing, I'm sorry, not containing, my bad, relating steps, parentheses x, to calories burned. That's the ugliest S ever. Y. And that's it. Like I said, scrapping number 11, so all you have to do is number 10.